Okay, good day, students. So for today, I will be continuing to discuss about some mathematical functions that are actually related to our daily activities, and some of these activities are already routinary. And in this class, in mathematics in the modern world, we will try to construct, or let's say, deduce a model from those activities, a mathematical model actually. So last years, you had your high school years, okay, and I believe that you already have learned about these models, but when you were in high school, they were termed as functions. Okay, the two functions that I will be discussing today are about the linear function. Okay, that's the first one, which is in the form of f of x is equal to ax plus b, and you are more familiar of this one, that instead of the f of x, you use y equals ax plus b. And from your handouts, did I already give your handouts? Well, if you already have the handouts, then you must have already read about some basic properties or characteristics of linear function. But if you still don't have it, then you listen. Okay, you listen carefully. Now, for a linear function, it says that a linear function is a first degree function. Okay, so let me use LF for my linear function. So it is a first degree function, and if you notice, the variables y and x, they are in the first degrees. Okay, your y is raised to 1, your x is also raised to 1, and that makes this function, this equation, to be linear. And of course, we have the constants a and b. Okay, and then you also have learned that for a linear function, it will give you a graph of a straight line. Okay, now introducing to you the next function, it is about a quadratic function. And for this time, a quadratic function is in the form of f of x is equal to ax squared plus bx plus c. And again, you are more familiar that instead of the f of x, you have your y is equal to ax squared plus bx plus c. Okay, and then if you are going to notice, this function also has two variables. You have the y and the x, and one of them is at the second degree. And if one of the variables in your quadratic function is raised to 2, then that makes this function or equation quadratic. And again, in quadratic function, you have three constants, your a, b, and c. Okay, further, let me have QF to be a short for quadratic function. And just like what I just like what I have said a while back, quadratic function is a second degree function, and it will give you a parabolic curve or a graph of a parabola. Okay, so I hope I am helping you to recall some important characteristics or basic characteristics or properties of linear function and quadratic function. Okay, so let us now go to some examples. Let us have this table of values. Let's say, I think I already gave you this example last time, but let us have a review. So it was about a jeepney ride. Okay, so for a jeepney ride, students are paying 6.75 per head. Now in this discussion, I'll be rounding that up to 7 pesos. Okay, now let us have some notations here. So we are going to let P be the number of passengers, and then A of P would be the fare. Okay, let me put this aside. Now, if you're going to construct now a table of values, so this is my P row, and this is my A of P row. So of course, if there's a 0 passenger, then there's a 0 fare. For 1 passenger, that passenger will be paying 7 pesos. And if there are 2 passengers, then it will cost them 14 pesos. 3 passengers, 21 pesos. And then how about if there are, let's say, 17 passengers? Then of course, how much will it cost them as a fare? In reality, you don't have to do this set of table of values, of course, or this table of values, of course, no? Because if you are already there, and then there are 17 of you, like you have 16 friends plus you, then you will just be computing, like, since each one of you will be paying 7 pesos, so it would just give you 17 times 7, right? But by this time, for the sake of giving you a formal learning about how this is going on in real life, so let us relate this to a function that we have learned in mathematics. And that's actually the essence of being in this class, okay? Now, the question is, how are we going to identify if this table of values is on a linear function or on a quadratic function? So first thing first, you should have the inspection of your independent variable. The P is the independent variable because it is causing the change for this variable. And this is changing according to this one. That's why this one is considered to be the independent variable. So your independent variable, the numerical data here, should have differences that are the same. So let's exclude this one. So let's start with 3. So 3 minus 2, that will give you 1. 2 minus 1, that will give you 1. 1 minus 0, that will also give you 1. So there you go. The first condition is satisfied. So after doing this, then let us now proceed to the dependent variables. Then your dependent variables, for your dependent variables, we should also do the same. So that's 21 minus 14, that's 7. 14 minus 7, that's also 7. 7 minus 0, that's also 7. So the first differences are the same. Okay? So let me write it here. If the first differences of the dependent variables, if the first differences of the dependent variable are similar, then it is a linear function. Okay, so let's go back to the idea that if it is a linear function, it should follow this pattern, this model, this equation or function, well, whatever term you want to name it, it's fine. So let us have this, y is equal to x plus b. So let me write it here, y is equal to ax plus b, since it is a linear function. Okay. Our dilemma here is we're going to find the model for this problem, a real-life problem. And the model is needing for the constants a and b. And from this table of values, our y will now be a of p, and that's still a, and our x would be p, then plus b. Now, to find the model for this problem about the jeepney ride, so that we can find the next values when p is varying, okay? Let me use the first set of points, the 1, 7, okay? P, and the 7 here would be the a of p. That's why this will give us 7 is equal to a times 1, which is our p from here, plus b. And then simplifying further, so we have 7 is equal to a plus b. So just like what I have mentioned back here, we need the constants a and b. But since we cannot find the a here, because we do not have the b, and the same thing as looking for b, but we do not have the a. Okay, so take note of this. So that's why we will still be needing another set of points for this problem to be solved. Let me use the 2, 14. Okay, 2, 14. So 2 now would be your p, and 14 would be your a of p. And that will give us 14 is equal to a, your p is 2, plus b. Simplifying further, so 14 is equal to 2a plus b. There. So take note of this. Two resulting equations from the two set of points from this table of values respectively. And since we are only referring to one problem, that means the constant a here is the same as the a here. The constant b there is the same as the b here. For example, if your a is 3 here, this is also 3. If your b is 4 here, b is also 4. And there are many ways to solve this. You could have graphing, elimination, or substitution. So for this problem, I'll be showing you, and I will help you to recall the method of the elimination and the substitution. I could also give you the graphing method. I can also show you that. But the thing is, in graphical method, that's less accurate than the two other methods, because that depends on how you graph. Okay, So let me concentrate on the on the two methods, substitution and elimination. Okay. Now let us have by substitution. Okay. So from this equation, I can have my A to be 7 minus B. So that is just by merely transposing, because that's what we have learned from high school. And this A here, just like what I have told you a while back, this A here is the same as the A here. So by substitution, this now will be 14 equals to, instead of writing A, then we will substitute that A with the 7 minus B. Then plus B. So by continuing the solution, that will give us 14. 2 times 7, that's 14. That's negative 2B plus B. Then you transpose the 14 here. So 14 minus 14, that will give you 0. Equals negative 2B plus B, that will give you negative B. Then divide both sides by negative 1. So this will give us now B is equal to 0 divided by negative 1, 0. There you go. We now have the B. So how are we going to look for the A? Let's go back here. So the A here, so let me have that. There you go. So the A, of course, still A, because that is what we're looking for. And then 7 is still 7. And then we now substitute B with the 0 that we have found here. So that will give us 7 minus 0, and therefore A is equal to 7. And there, we already have our goal, which is to find the constants A and B. There, right? Because, wait, this is the method for this one, and just like what I have said a while back, to find the model for this one, we need the constants A and B, and we already have found it. A is the 7, B is equal to 0, and that is by substitution. Now before I will reveal now the model, let us have the other one, which is by elimination. So let's go back here. So the second method is by elimination. Okay. So I hope you still recall this from high school. Okay. So let me have again 7 is equal to A plus B, and then 14 is equal to 2A plus B. Now by inspection, it is easier to eliminate the B. And how is that? And remember, when you do elimination, that means if you're going to perform the operation here, especially the addition, so B, the B here and the B here, if you perform the operation there, like addition, it will give you 0. So therefore, to eliminate B, one of them should be negative. And let me have this 1 multiplied by negative, and it will give us negative 7 equals negative A minus B. So anyway, when you say elimination, if we want to eliminate B, that means we are going to solve for the value for A. And let's see if we will be having the same value of A that we have found from the by substitution, which is 7, in by elimination. Okay, so let me put this beside this one so we can compare. Now, let's continue. So of course, the second equation will still remain the same. Now let's do the process of addition. So negative 7 plus 14 will give us 7 equals negative A plus 2A, that will give us A, So negative b plus b, and that will give us the 0. There you go. See? We get the same answer by substitution, by elimination. Now, let us have b, to solve for b by elimination.